Official recording. Okay, hi. Welcome to the Science Circle. This is our Moonbase project group meeting. We generally meet at this time on, actually we meet on Mondays, but June is our field trip month. And this is the first field trip of 2025. What you're seeing here, and you can walk on this, it seems like, I'm on a clear space, but you can walk on this. What you see below, by the way, is a picture of the moon and all the different places people have landed, including the moon above. There, I need to update it. The last couple of years have been very busy. Where Ariane was, this is what you see around you is a lunar landscape that covers what looks like almost 9 regions. Ariane is standing by where we are right now, the 2 red ellipses. And this is the large crater that is in this general direction over there where it says education and construction. And we're going to go visit the draft of the build. Now where Guy is over here and says, this is Stem Island. This is where the earlier builds are, the 3, you can actually see the 3 pillars. Actually, you could if it wasn't blocked there, but there's 3 pillars that represent where we had our earlier versions of the Moonbase. And we're going to go see, well, actually, that's a good point. Says this is either drafty or it's, consider this possibly a LED in the future screen where it moves with you and stuff, kind of, and if it weren't like that, then what it would look like would be totally dark. And we've considered those sorts of things on the moon. So, okay, without further ado, let's go over so what you're seeing here is a version, or is what the landscape looks like. Now, if you're over where Myron is and you look below, you will see, or if you just do your camera below, if you come over here, what you'll see is where the other versions were, or still are. It takes about a 5-minute drop to get to there, or 5-second drop to get to there. It's about 1,000 meters below, and that's where the immersive experience was for the virtual World's Best Practice Education Conference. Now, over where Op is, and Dottie, if you'll follow me where it says ethics, we'll go over to the next chamber here. Okay, this does not have a protective cover, so you can fall through like this. So I would recommend kind of just standing on the outside. Whoops, excuse me. Okay. So this is a plan, a 1 to 10 scale plan of the 4th version of the Moonbase. You can see how ambitious it is. This diagram here is a functional diagram. The one I'm standing under is a functional diagram of version 3. And then compare that to version 4 over on the middle. Now in here, we don't have time today, I don't think, to go through all of this. Oh, the scale. Okay, scale of this one is 1 to 10 scale. So if it were, for example, the sphere that I'm standing on right now is in the model, it's 3 meters across, and it would normally be 30 meters across. By the way, this is the power plant. The power plant would be a nuclear mini reactor, and it would not be anywhere near here, but it needs to be in the model for so we can work with it. Now, by the way, this area contains 3 sections. One is this one I'm moving up and down. This is the main control section. Essentially, it has the people that control each of the different areas, such as communications, food, personnel, the maintenance, and other features and stuff like that. Okay, so there is also, for example, this one right here would be there are some things on the surface. So, for example, that represents the communication towers on the top, and then the rest of the ring, the one in the middle there, is what we're going to go see, which is the medical bay, which has been completed up to the point of adding all of the stuff in it. There's also what we haven't completed in the model is this part here, which is a decontamination airlock shuttle to the landing site and stuff. Now, if you look out behind you, over this side, in fact, behind Ariane, you will see a full-size version of the SpaceX Starship, the largest rocket, or not, yeah, well, largest rocket and moon spacecraft ever built. Yeah, and I see Ariane going over there for scale. Good, thank you. Okay, and now she's walking back over here. Good, I'll wait. There she goes. Okay, flying back over here. I'll wait till she gets back over here for a second before we go to the rest of the thing. Please, if you have any questions, comments, etc., or if you're a member and want to add something to what I'm saying, I'm just showing you what our plans are. Now let's go see what some of what we've actually done. I'm not sure about contract or anything else there. We'll see. I mean, it's so volatile, you don't know what's going to happen every week. For Ariane there, you can fly through here. Okay, so let's walk into here. Follow me into here. And I will go down to the end and turn around for a second. And if everybody will hang around here for just a second. You can come all the way down here. Now, in this tunnel here, we have different, in the Moonbase version 4, we have different sized tunnels, if you think of it. For this one right here, what do you think size-wise? If you look at how many people are in here, what do you think this might be designed for? Anybody in chat? I always like to ask stuff in chat. Make sure everybody's all okay. Anybody guess? In other words, how many people could this accommodate, or what would the tunnel like this be? This tunnel is about 7 meters across. While you're thinking about that, if you look behind you at the different diagrams, so you can take a look at the diagrams. Okay, so Sis asked, where did we get all the details? Which details are we talking about for Sis?
Well, you have a number of different modules, and where did you get all the different modules from? Why is it done with such a modular design instead of a big dome? Why arranged in the particular way they're arranged? I mean, there's so many questions we can ask.
Okay, and that's those are all excellent questions, because sometimes I forget that our Moonbase meeting has been going on for 2.5 years now. And so I tend to, for people that are unfamiliar with this, I may tend to gloss over things which I remember us trying to think about at the very beginning. Okay, so that's a very good question. Is what we were trying to do at the very beginning was And in this one, if you look behind you, it says phase 1. And phase 1 was essentially, how is the moon different? How is living on the moon different than living in a space station or on Earth? So in answer to your question, Sis, what would living on the moon be like? How is it any different or alike than living on Earth or living on a space station? Anybody want to chime in on that one? Or if no one does, you can pop in there, Sis. Gravity, oxygen. Okay, so Max says yes. Very low gravity. On the moon, it's 1/6 gravity compared with the Earth. And then, of course, the International Space Station, it's 0 gravity because it's in orbit. So gravity is one thing. But one thing, tempo, it might very well be. Temperature, okay. The other part of that is temperature, gravity, oxygen for sure. Now, when we say oxygen, you're really talking about pressure, which answers part of what Siz's question is. The reason why you see a modular approach and cylinders and spheres predominantly as far as the design is that you have 1 atmosphere pressure with in other words, air on the inside and vacuum on the outside, both on the moon and the International Space Station. In order to contain that kind of pressure, a black sky or a starry sky, like a submarine, exactly, Ariane. In other words, in order to contain that type of pressure, you would need to have a pressure hull, something that could do that. A tornado, for example, can blow a house apart, but a tornado only is changing the pressure by about 20% at the maximum. So if you were to build something with walls and corners and such, an engineer will tell you that's not going to hold up as a pressure vessel. In other words, something that could contain an atmosphere of air. So that's one of the reasons why the shapes of cylinders and spheres. And then the other part is a modular design could be built. If you think about it, a sphere or a cylinder could be built by a 3D printer. If you had a 3D printer standing where one of you are right now, it could easily build around it like this, as if it's a tunnel or a sphere. Okay. Yeah, and you can definitely answer in chat. One of the things we find that's most helpful about Second Life and chatting as well as voice is that you can ask questions, answer them, etc. in chat while somebody talks. You can't do that in First Life in a say a presentation, lecture, classroom, that sort of thing. Arian also has a point there. Now, Arian has been one of our principal members, and we want to avoid radiation. So what you will see here coming up is not where the moon base will finally be. It's simply being built in the crater because it's easy to see and easy to move around, but you would need to build a moon base either under the surface of the moon, or it would have to be covered by a lot of regolith. In other words, regolith is what you call the soil, but there's really no, about SPF 2000 sunblock. Now, when we say radiation, we're not just talking about UV, though. So SPF 2000 wouldn't work if you're talking about X-rays and cosmic rays and other stuff. The other thing is that a particle radiation, perfect guy, is that unlike on Earth there's hundreds of tons of dust that's entering the atmosphere, everything from microscopic to marble size, entering the atmosphere every single day. And it all burns up in our atmosphere. But on the moon, there is no protection whatsoever. So you would be, if you look, when they looked at the lunar regolith, the moon rocks that came back in the Apollo and up till now, you will see tiny little microscopic holes where things have gone through it, say 15,000 kilometers per hour. I just pulled that number out. I know it in miles, but I'm not sure what it is in kilometers. But in other words, very fast projectiles, faster than a bullet, and it's made little trails of glass through the lunar regolith. You don't want bullets going through your moon base or through people or equipment or anything else. So we would build the entire base under the surface of the moon. How to do that? I don't know. We have envisioned, in fact, over where, right back here, where Myron is that we have envisioned on the moon there being lava tubes. Dolly, absolutely. We've talked about it. They've actually found evidence, as much evidence as they have of water ice, of lava tubes on the moon. If you have not seen our immersive experience, these pictures are from the Virtual World's Best Practice in Education immersive experience. And thanks, Sis. Sis is our resident comic. And he's very fast on, yeah, no giant sandworms, nothing like that. But the big thing was in phase one, and let me move around and you don't have to follow me right at the moment, but in the very beginning, what we looked at was kind of the physical part of it. In other words, how do we get air, water? What do we do about gravity? How do we attend to, essentially, for you guys that happen to know Maslow's hierarchy of needs, we're talking about breathing, water, food, sleep, temperature regulation, shelter, and safety, health, that sort of thing. that would be quite something, there says. Okay, so that was kind of our first phase, and then we also, as Illing's looking at over here, and Chantal, is that we were looking at, well, what have they done in the past? What were the lunar missions, the Apollo missions, the International Space Station right now? In other words, we're looking at what we know right now, and then how would it differ on the moon compared to what we know right now? Tagline, that's a very good point, and that's part of the reason why a regular orbit around the moon would not work very well, because there's a lot of gravitational anomalies, and your orbit would be very wobbly, and it would lead to mass-ons. That's actually the correct term for that. And so mass concentrations. And so what would happen would be a wobbly orbit that would lead to colliding into the moon. So they think that even for the Apollo 11 command, not the command module, but for the LAM part of it, they thought it could be an orbit, and they think that some of the others might be, but some of them have degraded orbits that have brought them into collision on the moon already. But that's another interesting story. Okay, so I'm going to kind of wind my way through here without running into anybody, hopefully, and show you the next part. Well, there you go, tagline. If you could drill into it. In other words, we haven't quite worked out how to build a large group of buildings under the surface of the moon. By the way, the regolith is simply an accumulation of dust and things of large size, everything from dust to large boulders that were ejected from collisions of the moon. Underneath that is a fractured surface, and the regolith can be anything from shallow to many tens of meters deep. Now, in the middle here, this is a nice view of kind of our draft of what we're building, or part of it anyway. The section to the left with the big racetrack is the medical bay, and then to the right is the command and control section, although that would actually be above the medical bay area. Now, this large sphere behind you, behind Ben and Radrum and Tagline, is a 60-meter sphere, and it represents the size of the first, on a 1 to 10 scale, the size of the first versions of the Moonbase. version 1 and version 2 were both built inside a theoretical 60-meter sphere. Why 60 meters? It's the largest object you can build in Second Life. Plus, it worked. Okay. Now, Ariane is headed down this way, which we will. So phase 2, we kind of said, okay, we know enough about the moon now, and we know enough about the effects of the moon and how hazardous it is and all that. So what would the moon base look like? So the first one we look like here near Syri and Ariane, and if you kind of turn your head slightly at 15 degrees, which is what the tunnel is, this was a diagram of our first moon base. Now this is built in full. You can actually find this over on the Immersive Experience. Only right now, the only part you can get to is the greenhouse on top, which you see on the right. Now, Delia, is Delia here today? Let's see. I thought I saw, yeah, Delia's here. And Delia will be giving us a full presentation on Monday, if you want to come to our main Moonbase meeting, about what she built there. For the Immersive Experience, she's got a full hydroponic gardens and other facilities that she imagines there, because they have, in one of the Chinese landers, they actually had seeds, and the seeds germinated and made a little plant. And so they've proved that, except unfortunately they weren't shielded, so they died within a few weeks. But you can grow seeds and such on the moon. Now, I actually was at a water resource event yesterday, and a guy showed me, he's pretty nearby, but he has a large hydroponic farm, and he showed me all the types of stuff that was built in is in this hydroponic garden, and that's kind of what we envision for our moon base. Now, does anyone know where we get water on the moon? Okay, Dolly actually has brought up one from the tap. Culligan Man. Oh, Culligan Man. Okay. Well, actually, tagline okay, now let me look at all the different things that you guys have said and count down. Okay, one of the things that Dolly said was urine. Okay, water would be way more precious than gold on the moon. And so on the International Space Station, they actually have a three-chambered, I'm trying to remember what it's called, but what they do is they have a 98% capture of all of the water that they use, including urine, including condensation, including sweat, including all of that, and they are able to purify it better than any water you can drink here on Earth, and with a 98% efficiency. So absolutely, we would capture every bit of water we could. Underground ice, I'm going to skip down to Ben's comment, is what they've been looking for. In fact, the last couple of spacecrafts, if they had not crashed, unfortunately, and there's a lot of reasons for why they did. In some cases, it's because of the shadows and stuff. But ice mining, absolutely. So on the moon, in the what's called permanently shadowed craters, which the crater that you see out there, that big one, would mostly be in a shadow, and the base of the crater would be something a minus 200 Celsius, similar to, say, Titan around Saturn. And so ice would come in a couple forms. One would be pieces of it that might be as big as, say, your hand, and then others would be adhere to the rocks there, and then other parts would be in the rocks. And so you could mine both the lunar regolith itself as well as the water that's contained in it, and then because of the pressure, you've got to bring it back in a pressure vessel to a water plant that would then extract it from the rocks, and now you'd have water. Now, what can you get from water? Besides water, what else can you get from water? Any chemists around here? I know there's chemists. Oxygen and hydrogen, absolutely. What can you do with oxygen and hydrogen? Well, oxygen, you can do lots of stuff, and hydrogen, same thing. Hydrogen, of course, you can use in chemical manufacture and for fuel, absolutely, as Myron just said. And oxygen you can both breathe as well as use in oxidation experiments, biochemistry, all kinds of stuff. So in other words, if we can mine ice, water, breathing's kind of important. So, by the way, in the International Space Station and in the Apollo missions, they tried a lot of different experiments. And here again, I've got to watch my timing because I want you to see the medical bay. In Apollo, they tried different variations of how much pressure and oxygen and stuff. And by the International Space Station, they basically said, look, the human body is used to 78% nitrogen, 21% oxygen, 1% argon, and some random change in humidity and carbon dioxide and stuff. Carbon dioxide, anybody happen to know how much carbon dioxide is in our atmosphere right now on Earth? Oh, somebody knows exactly. Okay, yeah, of course. Yeah, there you go. Okay, so it's not a lot, but it's obviously enough to make a difference. Now, we would be in the International Space Station on the moon, we'd actually be having probably a little bit higher carbon dioxide concentration because it's kind of difficult to scrub that. So, any case. But on the International Space Station, they essentially have the same atmosphere as on Earth because that's what we grew up and that's what our body expects. And so that's what we would probably have at the Moonbase. It is possible to bring all of the nitrogen that we would need in the base on one starship. In other words, if you had it in liquid form or even solid, you could bring the whole thing up. It wouldn't, my first degree was in chemistry, there wouldn't be a whole lot of difference between liquid and solid as far as volume. Okay, but look at this diagram here. This is our first moon base, and essentially you have two parts. One is if you're over on the left, you'll see a sphere with multiple layers, and that was kind of the working area, and then we envisioned a living area. But we came to a couple conclusions. One is it looked too much like a building on Earth, basically a high-rise, and then you commute home to a high-rise. And it also had traffic problems, in other words, the central elevator, balconies. We thought of a power plant, actually we didn't think about that yet. But in any case, there were several deficiencies about this model. So we thought about other model. And here we go. Ariane is ahead of us here. And if you'll come down this way, what you'll see is in Ben's direction, you'll see some of our concepts. They're much more sophisticated right in front of Ben right now in Illing. This is a side view of the cargo entry, and you'll see all of these. Now, Sis also asked, where did we come up with the idea of all these modules? Well, what we did was we looked at all of what NASA's doing. I don't think so. There's plenty of room, Ben, here to look around on these. Plus, I made them large enough that I don't think any one person can scare them. Plus, we got the camera views, but thanks for asking. And so anyway, one of the things we did was we looked at actual diagrams that NASA has put together since 1989. Okay, Sis, that's a good question, and I'm going to be answering that here in a second. We looked at all of the diagrams that NASA's put together, all of the ESA diagrams, the ones from Japan and Canada, and lots of other different places, and that have thought about moon bases. And then they've also had contests in schools, from college through secondary school and stuff. And so we looked at diagrams from Turkey and Sweden and Japan and China and lots of places all over the world. in the contest. And then we said, these are the modules that we think we would need in our Moonbase. And then there's other ones that we didn't. But we said, okay, well, what are we doing at the Moonbase? We're doing research. So obviously there would be large research and chemistry labs. We would need to manufacture what we used. So there'd be manufacturing. There'd be a power plant and cargo storage and a place to repair and to create the air and water. And some person said, well, why don't we have a track, okay, to keep fit. And then we were thinking, well, okay, great. Dining rooms, food preparation, places to a medical ward with isolation, greenhouse, quarters, and lots of other areas. Entertainment, like you could have VR or other stuff. Sports, other types of stuff. But we had to consider, well, what was the main things we were doing? So a lot of those, if you think about it, now why the particular arrangement of modules? The arrangement of modules, that's actually a good question, and let me kind of give you the answer right here, is that near where Gazanides is, let me come down this way, it's back up right where across from Syri, this one that says modules and connections. We knew that we wanted those modules, but what we wanted to do is we came together and we said, okay, functionally, what should be connected to each other? Well, tagline, that's a very good question, and you can either have open space, so to speak. Now, in version 2, even though it was within a 60-meter sphere, I envisioned being able to look out from the different modules as if you were in a city and getting the sense of open space. So, for example, 60 meters was quite a distance across. You're talking city block sort of distances across. And you could also, yeah, there you go, grow trees if you can, as far as the hydroponics and stuff. We still have a lot to talk about, or to think about, and so you can have a sense of a view. You can have, much like we have back in the ellipses that show the planning, you can have basically pictures that are 360 around, like what Disney does and stuff, and you can see a 360 view of any place you want to be in the world or beyond the world, that sort of thing. That's also part of the reasons for cylinders and spheres, is they have high ceilings, which give a little bit sense of openness, better than a building with a limited flat ceiling. All that good. And absolutely, habitability. I happen to be a retired Navy officer. I'm pretty familiar with how ship designers have do their thing and what's in it and what kind of modules there are in ships. But so, yeah, absolutely. So anyway, we thought about, if you have repair and recycle areas, it would need to be near a manufacturing area. You'd need to have storage near there. You'd have to have, here again, food, dining room, food preparation, food storage, all of those areas. Those would be, the food storage needs to be near a greenhouse. No. Now, the interesting thing is I am working with, two people right now. One is a world famous, or U.S. famous anyway, architect who has built a number of buildings in Silicon Valley and other places. And he's talking to NASA about the people that are working on some of these actual problems. And so what we're trying to do is get them, first of all, take us seriously, and then share what we're doing along with hopefully them sharing what they're doing. Fortunately, it's not a national secret what the designs are, I don't think, yet, anyway. So we'll see. Okay. Now, Insert quarterlies. Okay. So now near tagline there, and Max to the right of Max, in fact behind Max right now, there is a photo of our version 2. Now you can see that that's with transparent outer area that you can see the different spheres inside and modules and stuff. It's easier to build that way is if you've got some transparent walls and all that, so you can see how everything works together. Okay, now this is phase 2. In other words, what would a Moonbase possibly look like? So let's continue down through in the tour. Is phase 3, and then this one here, where Syri Sis is. I'm just stopping before it. Illing Guy is right here. This is a photo of our 3rd version of the Moonbase, with each one is a little more sophisticated as far as how the module. Okay, in the spaces between the module have an atmosphere. Okay, the answer is no. This would be built in, say, a lava tube or something. Now, in the case, though, of the ones in this is version 3. I'm standing in front of it. This one, no. In other words, that would not have atmosphere. However, in version 2, where it was all contained within one 60-meter sphere, you could have atmosphere in that sphere as well as atmosphere in the modules to kind of double on the security of leaks and stuff. But in addition, once we started talking about, well, what should the Moonbase look like, then we said, well, what about human aspects? And we said, well, okay, Guy, what's up? Okay, I'll wait for your chat there. Yeah, staring at a poster. Okay, but we were thinking like somebody mentioned about naval architecture. What is the color inside a Navy ship? Plaid. Gray. Okay, maybe somebody's been in a Navy ship. Yeah. In other words, there's not a lot of color in a lot of areas. And actually, having been on ships for at least 8 years of my life floating around, yeah, blue, there's not a lot of color. So actually, when I went ashore, in addition to trying to get my sea legs again, so to speak, is that the color green, the smell of a flower. I mean, those were all intense sensual experiences when I came back onto shore. It's something that you miss. You might see a lot of blue at sea, but you don't see a lot of other colors. And so it was something. So in other words, you'd want to have color. You'd want to investigate color. What about artwork? What about? Yeah, I'm reading what you guys are texting. But what about color, natural materials, and textures, art, senses of space, like in other words, not being in tubes or spheres for months at a time. What about an outside view, which could be on an LED screen? What about sunlight? We were thinking actually from a circadian rhythm standpoint that you could mimic light. In other words, you start in a room even. You start with, well, I'm not sure about dogs playing poker or, but if you want it in your room, that would be fun. Okay, so we were thinking, in other words, now we got to the end. What about mental health? In other words, what keeps your mind busy? You can't just be at work all the time. There must be other types of things that you can be doing aboard for months at a time. How long would you want to stay? What could we do to make living aboard a Moonbase meaningful for people to think that what they're doing is meaningful? All of that sort of stuff. Like, what about moon art? In other words, would it be as important to have an artist aboard as it would to be a mechanic or a poet or something? So all of those sorts of things were ones we've discussed. If you're interested in all of these things, then we meet regularly at this time on Mondays, and we discuss a lot of these types of things. We are going into, and which brings me up, so that's phase 3, what are human aspects. Let's continue with the tour here. This is another version of the, this is another version of Moonbase version 3. In phase 4, we basically shared what we learned at the Virtual World's Best Practice Education and in a MOOC conference. The photos you have on the wall, up till now we kind of built draft models of the base, and we didn't fill in anything. So we asked Op, who is a good illustrator here, to go, okay, what would you imagine the base to look like? You lost my voice because I was on speaker, so I said a whole bunch of stuff and nobody picked it up. Okay, so in phase 4, we kind of said, what would be the details? In other words, we first of all shared what we learned in the Virtual World's Best Practice Education conference, and you can go see that anytime you want. It's immersive experience. It's below us. All you actually have to do is fly over there and drop down about 5 seconds, and you'll be there to the north of us. Okay, so Op, who is a good illustrator, we said, well, can you envision what inside the base might look like? And she came up with some diagrams, and they kind of look retro in look, and they're pastel colors. And so this one is kind of interesting. She envisioned a library. Well, why not? Instead of having books, you basically say, artists, absolutely, Guy, is you kind of say, okay, could you have a space that looked like a library, but instead of those being real books, there's something you could plug in to, say, a personal book that you have in your hand, sort of thing, like the old ink idea. And so now you actually have a book in your hand and a quiet space to read and stuff. In other words, from a mental health standpoint, we said, why not? Why not music? Why not other types of things in order to, because in order to work, yeah, better than Kindles, in order to work on a base, you need to be mentally prepared and be able to have sleep and the whole bit. Okay, let's continue going. Okay, so we also asked, look at the diagram, both diagrams. The one with the square-looking diagrams is Tagline, who is a retired surgeon. I hope he doesn't mind my divulging that. He designed a medical bay. And so he designed a medical bay, and his design is the one that looks like it would be on Earth, in other words, the one to the left there. And then I kind of did the module version of it on the right, the one that Sis is looking at. So let's go look at that. In other words, this is a fully fledged thing. The purple, I just picked a color out of the blue, so to speak. Purple means medical. Okay, so this is the medical bay where Ariane is right now. You have 3 different directions. We're going to go down the routine care direction, but you have routine care, critical care, emergencies, red, yellow, green like that. Tag might want to weigh in on some of this because this is his design. Like I said, I built it. Oh, it does? Sorry, Tag. We'll come up with a better one. So green, routine care. Where Sis is, by the way, you can get lost. Somebody pointed out that if you have modules, it's easy to get lost. So you have to have both signs, maps, and colors. So you can see you are here, right there, in the green area. And so you'd have a reception area with a bathroom in the back or toilet. This is toward the treatment area. So you might have a pharmacy here. Let's continue down here. This is one of the duty rooms, in other words, overnight rooms for medical staff, in case there was an emergency. Delia found an interesting door, if anybody wants to click on one of the doors. There you go. And it isn't fully furnished, so to speak, but there you go, Ariane. You get a little privacy in the toilet there. You'd have to think about locking it, etc. Or say the medical staff. Here, you'd have a little room, and you'd have a place for the medical. I don't know about that bed, but basically you could. It's a duty room. Yeah, Deep Space Nine. Oh, there you go. Okay. So that's part of it. Let's go back up then to the, let's continue to the treatment area. In other words, do a 180 here, and then 90 degree to the left. Follow me down this way. If you have any questions, please. So for example, we have a couple, this is the map here in the treatment area. We've got a couple treatment rooms. There's a kind of futuristic looking examination table in that one. Now, we have not fully furnished any of these areas because this is not where the Moonbase would be. Where would the Moonbase be? That'd be on a quiz. Where are we planning to put the Moonbase?
On the moon?
Well, it would be really nice to put it on the moon. But barring that, at least underground is what Dolly said. In other words, we would have it underground. Why? This is the quiz part of the... Okay, lava tube, if we could find it and it was convenient. Absolutely. In other words, both micrometeorites as well as a number of different types of radiation. It needs to be protected. Remember that the International Space Station, for example, is protected by the Van Allen radiation belt. In other words, it's well within the first belt, and it's also close to the Earth, and so it would have a lot more protection than the moon. In this case, if you were not under the surface, you would be you'd be in the direct line of the solar wind for 2 weeks of the year, and then the rest of the time it would be cosmic rays and micrometeorites coming from all over the solar system, and you would be in bad shape if you're going to be here for months. In other words, way more than on an International Space Station. We've actually looked up the numbers and stuff, and it would be very similar to, it would be nasty. It would be, if you were here for a long time, it could be potentially fatal. Okay, so down, the last part here is our radiology lab. In other words, Tag designed this. Like I said, he's a retired MD, and he designed this area. I didn't hear you, Sis. Go ahead.
Yeah, I've been playing with the volume. Is this okay for people? Can they hear me okay? Yeah, okay, people hear me fine. Yeah, I've been playing with the volume. I've been told it's been a little loud before. Yeah, I have some comments about this, and Tagline might want to pipe in. Because, I mean, this medical area, it looks huge. I mean, we're supposed to have, what, only 100 people living on this moon base? Why would we have such a large area for treating 100 people? I have a couple of comments on that. One is, if this were a medical research moon base, then that would make sense. Another thing is, if it's not a medical research moon base, you wouldn't need to have all kinds of treatments here because you have, I mean, this is a third-generation moon base. There are other moon bases nearby. You'd evacuate someone to another moon base where they have a larger hospital, I would think. A moon base that's maybe like a small town. You'd have a larger hospital, and you'd evacuate people to there if it's something serious. If you have a medical research a moon base, then maybe you do want something that's large. I don't know. These are just some thoughts I'm having, and maybe Tagline can answer that.
Okay, Tag, if you want to chime in, but I was thinking about that too, and Tag designed it on the idea that it would be, in other words, this would be, maybe we do specialize in medical research. fact, one of the things we talked about was instead of just our being the only Moonbase, is that there might be ones that would specialize in different areas. And so since Tagline has already designed this, why not? You know, medical research, having a place that people can evacuate people to before they come or before they go back to a space station or to Earth would be a logical thing to do if you had a number of people on the moon. So I was wondering about that. I was thinking about that. Something we haven't talked about yet, but I think, yeah, there you go, Ariane. Now, speaking of which, Ariane, I envision having this thing here, the medical bay here, but also tiny clinics throughout the base itself, so that, in other words, immediate first aid stations where if you had a wound, say, in the manufacturing area, that you would be able to tend to that before being able to be transported here to the medical bay. And then if it was serious enough, then you'd have to go back to Earth, for example. Tagline, you want to say more?
Oh, can you hear me? I don't have my headset on, but can you hear me? Okay. Yep. I designed this with the idea that this is the closest facility and not just a triage site. If you do have a peripheral unit somewhere, you would want to have triage there and capabilities of transport. And eventually I could imagine underground tubes with high-speed vehicles between units. And one would figure there wouldn't be people walking in those. But I see the moon as an environment as pretty high risk for people that are out there doing work unless they've got, you know, robotics doing it for them. And even with that, if there are impacts on the station or, you know, fires like Gus Grissom experienced, I think, with electrical equipment, and things can go south real quickly. So I thought that it needed an ICU, it needed hyperbaric oxygen capabilities and radiologic capabilities and advanced support capabilities. So that's about all I can say right now. You know, medical care is expensive. If you don't have it, you're basically on the same footing as nature, where you figure on a certain number of people in the species dropping on the side of the road as time goes on, and you replace them with newborns. But I don't think a moon base is going to work well if you have people dying of things that can be treated in the proper, you know, with a trauma team and a well-equipped trauma team. So I'll stop there. Thank you.
Yeah, I'm just wondering if you need all that volume to do all that, because you know all moon bases, or there are going to be many moon bases at the period that we have our moon base, which is supposedly like 2050, 2070 or something like that, which means you're not going to have all the moon bases with all these hospital facilities like this size. So you'd have one moon base with a lot of hospital facilities that you really need, and you evacuate people to it, and others that would have less than that, I would think. I'm a Canadian, so that's the way I think. So.
Okay, but one of the reasons I did this was because Tagline was the first person to develop one of the sections in full detail. So and the other thing was to use his design as a example of how to use modular design and whether it would work or not. So this is, if you think about it, this is an experiment in modular design and the look and feel of a large area or base, and the idea of using color and signs and maps and what color the floor and the side, all of that sort of stuff like that. So in a way, it's kind of like a experimental design, even if we did not have a medical bay this big. But that was my rationale behind building this. Okay, let's continue to the other part because we've got about 5 minutes or so, so we don't go too far over on the hour. So anyway, this is the treatment area. We've seen the routine care. Let's go over to the critical care and emergency areas. Essentially behind you, I'll go out ahead and show you. And thank you for attending. If you need to go a little early,
I have one last quick comment.
Yeah, quick. Go ahead.
Just quickly, if I were involved in a project like this and I felt I didn't have the facilities that I would need to be able to provide care at the level I want to be able to provide it, I wouldn't go along with it. I wouldn't take part in it. And if this all happens and the world doesn't blow itself up, or other things happen, and we end up with lots of facilities, you'll have maybe a more centralized care and triage system, but otherwise you're going to potentially have trouble recruiting physicians to, it'd be like trying to get somebody who's highly trained to work in some podunk place that doesn't have anybody that understands what kind of work they do. They just wouldn't do it normally. So, and just make that point. Thank you.
Okay, so we do have some room for expansion possibly for families, though we've kind of determined that in our Moonbase, having a family, everything from conception on up, would present medical situations, particularly in a low gravity and radiation environment and stuff, that might be more than we can accommodate in our particular Moonbase. So let's go into this area just to look at what types of spaces we would have. So in hyperbarics, notice that with low gravity and pressure environments and stuff, we would need something like hyperbarics. Think the beds, like for divers. In other words, you normally don't have that in a hospital, but in this case you would have to on the moon because you could have pressure injuries. We have storage areas. Now, let's go back this way. First of all, let's go to recovery. In other words, you'd need a place for patients to recover after treatments, particularly operations and stuff. And I am trying to finish up around the hour here. And then back behind you, you can see where you are in the yellow area. And in fact, we'll finish up that way. Let's just continue down this way. I'll walk backwards here. The area that Max is under right there would be kind of a sterilization area to try to keep the outside of you sterile. The area that said storage would essentially go to a isolation ward, detention center. Although we've never talked about having police or anything. In other words, because of who we would have on base. But if we did have a detention center, it would essentially probably be here as a mental health issue. That would be emergency room there. Then behind Illing here and near Ariane, we've got a scrub room. And this would be a sterile area, scrub room, and then an operating room. I haven't found a good operating table yet, but it's an example of it. I see Ariane knows more than I do about medical. And then finally, This is our ICU room. Now, here again, would a bed on the moon look like that? Well, likely not, but that's what you can get in the marketplace in Second Life. So this is our ICU. Now, this actually concludes our tour because what I wanted to do, okay, let's just iterate. The first thing I talked about was our new spaces that we're working in. It's essentially a very large area. Well, the high rails might be necessary, or higher rails. Okay, so it's a very large area that we have to work with, much larger than we had before. We've essentially got two regions to work in. We're able to have a power plant that would not be near the base. In other words, if it's a nuclear mini reactor, you'd need to have some space for that, for safety and radiation. You might have a shuttle system that went to different places, communication towers, in other words, on top, but the base itself would be below the surface. We talked about the reiterations of the Moonbase, from a simple-looking structure that looked like a high-rise building to a more sophisticated system in a 60-meter sphere that had modules and other stuff, to a little more sophisticated-looking one in version 3. And so now we're looking at version 4. Like you've mentioned, this medical bay is very large for, depending on the number of people we have. But what you're looking at is the center of a larger base, which we haven't finished. And then it could also be the center of a number of bases. Let's presume that, for example, there are other bases. China is expecting to build a base. They're well on their way, more so than any other place on Earth right now, as far as their missions going and the success of their missions. And so there's no reason to imagine that in decades ahead they wouldn't have their own base. If we were all civilized enough to work together, we might have the central medical area for a number of bases before. And if it were critical, then they might have to transfer back to Earth, but that would take days to affect that sort of thing. So this is a experimental build for our version 4. We will talk about the modules and the spacing and colors and everything else that needs to be. Well, now that's a good question, Illing. Now remember that when you go to liquid or solid gases, that's 1,000th of the volume. So I would have to figure out, and it would be pretty easy with cylinders and spheres to figure out the volume of how much oxygen you would need, and then where you get the oxygen from. So for example, if the oxygen is coming from water ice, then you would have to figure out how much water ice you would need. But those are all the types of things that, and there again, Sis just made an interesting comment, that there's actually quite a bit of oxygen if we could extract it. Well, this would be, yes, okay. So in other words, I've given you a brief idea of what were the types of things that we're discussing about in our version 4. If you're at all interested or want to be a part of it, we meet at this time, in other words, 10 a.m. Second Life time, in the meeting area that we started at, and you're more than welcome to join us and contribute to our designing a virtual moon base and thinking about all of the aspects that are of living and working in a sustainable way on the moon base. Anyone else have some comments? Anyone that's been in the group for a while, or anyone else? Either in chat or in voice.
One thing. Okay, go ahead.
All I was going to say is this is a fun project, and it's neat, and but really it's more of a science fiction movie set. It's about look and feel as well as trying to be functional. You remind me of like Gene Roddenberry when they were trying to design the Starship Enterprise, and they wanted it to be both sci-fi and exciting and fun, but also believable in terms of functionality. But really, a lot of the assumptions that you're working on, a lot of these problems have been solved already for real world applications that we already have. So, look at the International Space Station and see what they did there. It's rectangular. It's a square as a box of saltines. You don't need to go with spheres and cylinders because the pressure differential is only 1 atmosphere. It's 14.7 pounds per square inch. You can build a stiff structure that can withstand a pressure differential of 14.7 pounds per square inch. It's not a problem. Submarines have to be round because they have many, many, many times, orders of magnitude more pressure on them than spacecraft or aircraft do. So you don't have to go with a spherical or cylindrical architecture when the only thing you're worried about is aerospace. You can go with rectangular shapes if you want to. There's many advantages to rectangular shapes. They're less expensive to build, as a general rule, which is why modern ships are now built like shoe boxes instead of being all full of curves like they were for thousands of years before that. So they're easier to build, they're cheaper to build, and they save a lot of space. And somebody was asking, how are you going to fill this place up with oxygen? And they're right. If you have a tremendous interior volume, that's more atmosphere you need to put in here. The smaller your interior volume, the smaller an atmosphere, or less atmosphere you have, and the less oxygen you need to worry about. So I think it's a fun project, and I'm not trying to dissuade anybody from pursuing it, but just recognize that there's some things that could be, if I was designing this from the ground up, it wouldn't look like this because I'd be looking at what's already been done. Another place that we see things that have already been done is Antarctica. So if you go to the South Pole, there is a really large base there run by the United States, the Amundsen Scott Station. It houses up to 200 people in the summer and about 40 people in the winter. If I was younger and not falling apart from old age, I'd apply for a job there because it's so much like being on a submarine, but much roomier than a submarine. But it's a good model for what you're doing here because of the size of the population and the fact that the external environment is so hostile, and it's got to support this population in there. Go look at the video. I put it up in chat, a link to one of the best tours that I've ever found of the place, just so you can look and see what you can get away with. And I think in terms of space planning, and I started off in life as an architect before I went off and did other things, and I still got one brother that's in the business, and he runs an architectural firm in Boston. And the bottom line is that in terms of space planning, the rectangle is the way to go. Spheres are terribly, no matter how attractive or fun they are, they're just not practical. If spheres were practical, we would drink Coca-Cola from spherical cans, and we would keep, breakfast cereal in spherical boxes, and on and on and on. Spheres don't work too well. We go with rectangles because they actually work better. Like I said, they're less expensive. There's less atmosphere involved. There's a world of advantages to rectangles. Yeah, I know all about the corners of the weakest part because when I ditched architecture, I got a degree in engineering and material science and engineering, and with specialization in metallurgy, and I had to learn all about design of things, and I worked on even design of submarines. And so, no, I understand about stress concentration in corners, but the thing that you're overlooking is the amount of pressure differential is only 14.7 pounds per square inch. That's not very much. And you can make that stout without having to resort to anything heroic. When your pressure differentials go up to hundreds of pounds per square inch, now you better be thinking about cylinders and spheres. But at 14.7 pounds per square inch, I think you can get away with this. The bottom line is that I think it's a great idea. But again, if you're trying to be strictly realistic, again, for a population like this, you don't need such a large hospital. I've worked in a hospital. When I was a college student, I worked in a hospital. I've been a patient in a hospital, I'm sorry to say, way too many times. And you don't need this much space.
Let me break in for a second. I understand what you're saying. We meet on Mondays. This is a field trip through what we've been doing so far. Let me reiterate that the reason why we built the medical center like this was for two reasons. Medical center. One was Tag made the design, and we used the design to experiment with module building, with sizes, with looks, feels of walking through and stuff. It may not have a practical application with regards to some Moonbase decades in the future. So if you're interested and would like to contribute to, in other words, you've obviously got some experience in different areas. If you'd like to contribute, then what I'd recommend is that you join us on Mondays. Otherwise, I appreciate what you're saying, but I'd like to wrap up the field trip for today.
Okay, well, thank you.
Yeah, one other thing I'd like to raise is that the pressure is not simply 1 atmosphere, as you suggest, necessarily, because we'll be building underground. And how far you build underground will make a difference. So having spherical shapes and cylinders might be a good idea. I don't know, but we can experiment with different shapes.
You do have a point there. You may need vaulted ceilings.
Yeah, so the idea is we're in other words, what you're basically bringing up is shape and design and stuff like that. And those are some of the things that we like to talk about, as well as the human aspects. So I hope you've all gotten something interesting from the field trip today. And as I mentioned, if you do have experience in different areas or just an interest, then I would like you to, or invite you to come on Mondays. All are welcome, science educators and the like. If you know anyone who is actually working on something like this, I don't. I've seen contents. I know that I did projects at NASA. I know engineers and architects, and they're all contributing to what we've been doing. Yeah, one other note, I think that Chantel must have put that in, is we have a naming contest. And we would like to get some names. I know of a couple names right now. So if you have a name for our Science Circle Moonbase other than Science Circle Moonbase, then I invite you to apply. There's a note card, or there you go, Looney Tunes. Okay, that's the third name I've heard. So hopefully you got something out of the field trip. This is a good group of people attending today. Thank you very much for coming, and I'm going to try to wrap up things unless anyone else has something to add. And I appreciate everybody's contribution.